Okay, so I'm back with a bang, and I guess you're gonna be very excited to know about whatever I'm going to teach you right now regarding the I2C communication. But what I want to say is that I'm just going to start you with a very basic, very basic, and this is just part one of all the 3 lectures. So it's part one of the 3 lectures that you're going to do it, and you're going to follow it very fast because it's a big thing that I'm going to cover, and I have to cover it in a very small amount of time because it's almost 12:10 right here in the night, and I don't want to keep awake all night. And about I2C communication, only one thing I can say is that if you have ever wondered that how do multiple chips communicate between themselves, then this is the only way that is most popular to date. And I can tell you, even on computer motherboards, even on recent motherboards, the hi-fi computers and mobile phones that we use, you have an iPhone, right? You have a gaming laptop, you have a gaming PC, you have whatnot, Android phone and whatever, anything that you use, it uses SM bus, and SM bus is a sort of an I2C technology. It's an extension of I2C technology as well, and I2C technology itself is used because if you see, there are several motherboards who install a particular driver only for the I2C communication. So inter-integrated circuit communication is very essential because integrated circuits will exist not in a single number, they will exist in multiple numbers. There will be several masters, there will be single masters, and the masters needs to communicate between themselves. The slaves never communicate between themselves, mind you that you should have this clear idea that the slaves will never communicate between themselves unless and until it is very much required. It's a very rare case where one slave will communicate with another slave. It might be, I'm not saying it is an impossible task, because you have a port expander where one input has to be transferred to another output. So here one port expander is a slave and the other is another slave. So but that has to be done through a master. So an I2C communication cannot happen without a master or multiple masters. Multiple masters can create complications into the system because it is a 2-wire system. When one particular master is communicating with a slave, and one master can communicate at a time with only one slave. So when one particular master is communicating with a slave, there can be another master who is wanting to communicate with another slave, or maybe that slave as well. So that condition is called arbitration lost, and that has to be dealt with very carefully. You must know where the arbitration is lost and how the arbitration is lost. Arbitration lost condition leads to many kind of complications, so that I will cover up in part 2, but not right now. Basically you need to know what is I2C communication. And for students who are very basic, who want to develop circuits using 8051, I have a lot of them. I'm not laughing on you. I have a lot of them. I love you as well. I have a lot of them who want to still develop I2C communication, and I don't know, I just don't get to understand that there are many people who still love to do bit banging methods. Guys keep on coming, keep on pinging on me, keep on sending me messages and SMSs and mails saying that I want to do this. Even when I'm on I am on E2E .ti.com, that is that is Texas Instruments Engineers to Engineers Forum. You will find me over there, and over there there are people who are really interested in communicating big data, big streams of data using bit banging methods. I will tell you, okay, I will discuss bit banging methods with you, right? Because I have a lot of students who will be very angry on me if I don't go for bit banging. But please, it's old, it's like you're trying to buy something of 1960s right now. So try to get rid of bit banging methods. It wastes cycles, it wastes your CPU cycles, your CPU. you guys must understand that you are into a 16-bit or a 32-bit microcontroller. You are into a 16-bit MSP or into a 32-bit ARM Cortex M4F processor, or an ARM Cortex microprocessor, or a microcontroller, right? So you cannot afford to lose cycles. Cycles are important for you. You cannot afford to lose energy. It may be that your system is running on a single coin cell. You cannot keep on, for bit banging methods, which is very important. What is done is, for bit banging methods, you keep on polling. No, you cannot keep on polling the pin. It's not done. You have to go for interrupt. You have to make the processor go to sleep, because energy is important. Energy is priceless, and energy has to be conserved, and that is what we all are. Recently there has been a summit in Paris, I guess, where energy summit in Paris, where we all are very, very much conserve very much tensed about this global warming. So how can you reduce global warming if you are not reducing the energy consumption? So please guys, I know you can do it with the bit banging method, but don't do it, right? So here we go. Part 1 starts from here. Right, so what is I2C? I've told you a lot of times. Basically, you have a master, say M1, right? This master has to communicate with multiple slaves, say S1, S2, S3, S4. How will they do it? One of the most brilliant procedures that was really discovered by Phillips was to use a two-wire technique. That is why it is called a two-wire interface. That is, just have two wires, and all the slaves are parallelly connected to the master. And mind you, this has no limitation. Well, it does. I'll tell you what limitation it has. As of now, just think that there is no limitation, and also think that there is one master. Now suppose this particular slave, what it does is it acquires some temperature data in 8-bit format, right? So when you are acquiring a temperature data in 8-bit format, what is your resolution? That is up to you to calculate. I won't tell you. So it is calculating the temperature, say from 5 degrees Celsius to 100 degrees Celsius in 8-bit format. This particular slave has 4 GPIO pins. each and every pin is pulled up. I hope you understand what is the meaning of pull up. Means each and every pin is connected to the VCC through a high voltage, through a high value resistance. So when you press the button, that particular pin goes to ground. So this particular system has a 4-bit format, because either all the buttons are pressed when it can send a data of 0000. When only one button is pressed, it can only send a data of 1110. When this button is pressed, it can send only a data of 1011, and so on, right? Now you can tell me, what about the other rest 4 bits? Well, you can just pad it as 0000. You know what is padding? Just filling up with you can say just useless data. It basically means nothing. Interesting is S3 can be an EEPROM, something that you guys love, say 24C02, right? It is a 2K bit. Now here is something I want to clarify. 24C02 is a 2K bit EEPROM. What is a 2K bit EEPROM? It means that it has 2K, that is 2048 bits of memory. So 2048 bits of memory, if you divide it by 8, will actually give you how much? That will give you, I think it will give you 256. 2048 divided by 8 will give you yeah, it'll give you yeah, it'll give you 256 bytes of memory. So basically you can only save 256 bytes of memory over here. Now this one is interesting. This is something that I call a port expander. What is a port expander? Port expander is nothing but, you will have 8 pins over here. 1, 2, 3, 4, 5, 6, 7, 8, right? Out of these 8 pins, you know, P0, P1, P2, P3, P4, P5, P6, P7. Some are, say 4 are outputs, and these 4 are inputs. Input meaning you can connect some wires over here. You can drop in 5 volts. If you drop in 5 volts, then it will send a 1. If you drop in 0 volt, it will send a 0. Now the master needs to communicate with all of these slaves as and when required, right? Sometimes it has to take the temperature data, sometimes it has to take the switches, say to understand that what type of temperature the user wants. It has to save the user's temperature requirement, and accordingly, you know, it has to take input from some other sources, and accordingly it can switch on some fans or some heaters. Now this is where an I2C communication comes into picture, because the master has to communicate with multiple slaves, but it has only 2 wires. One is called the serial data, and the other is called a serial clock. Now why are only two lines used? The reason is, that for I2C communication, for serial data and serial clock, the data line is used for some purposes, the clock line is used for one purpose. What are they? The data line and the clock line will tell the system or the slaves whether the communication has to start or not. Right? So what I will do is, I guess I'll just give you a 2-minute time. Just take a brief, just copy this down in your copy if you have a paper or something, because you will be needing it later on, right? When I will be discussing. And one thing more, remember, each and every I2C slave, these are called slaves, and this is the master. The master never has any address. The slaves have address. The slaves have a 7-bit address. It's a 7-bit address. It's very interesting. It's a 7-bit address. So when you have a 7-bit address, so what are the maximum number of slaves that you can have? So when the first address can be 0000000. The second slave address can be 0000001. The third can be 0000010. Right? So this is 0, this is 1, this is 2. So ultimately, if we go on like this, the final form can be 1111 111. And what is this? Can anybody guess? I know everybody can guess it. It's very simple. It is 127. So basically, for 7-bit addressing, this is the total number of slaves that can be connected to any I2C line. So as you know, I was telling you that this can continue. Usually this cannot continue. This is the first problem. So the maximum number of slaves has to be 127. But usually nobody connects. I haven't seen in my lifetime connecting 127 slaves. It's dangerous. It's literally dangerous. Believe me, literally. Secondly, there is something that is called bus capacitance. Bus capacitance is something that is very important. According to the rules, I would suggest you, I will give you, in fact, in my website, I will upload a document where you can find the details or the specifications of I2C bus specifications given by Philips itself, that there has to be a fixed bus capacitance, that is the capacitance of the SDA bus to the ground, SCL bus to the ground, and the SDA and SCA buses has to have a value, and your clocking, that is the rate at which you will send the data along these lines, will depend upon the capacitances, the bus capacitances. You can't just have an I2C line running 10 kilometers and you send data and say, oh my god, why the hell it is not reaching there. No, it will never reach. You have to calculate the clock speed, at what speed you can send data depending on the bus capacitances, the several, when you are connecting so many slaves, the slaves will also put on some loading on the bus. So all these kind of considerations you have to take into picture, which are mentioned in the document. You'll go through the document. If you have any problem, you let me know, I will clarify. I can't tell everything over here. So that is one more point. And the other is that for any kind of for sending the clock, for any kind of serial, I presume you've covered synchronous communication before moving into this particular video. So for any kind of serial communication, synchronous serial communication, the clock speed is very important. So here usually we go for 100 kilohertz to a 400 kilohertz clock speed. This is the limitation of the clock speed that we always recommend, that even Philips recommends and everybody recommends for I2C communication. But let me tell you, Texas Instruments have been able to develop I2C communications with 10-bit addressing, not 7-bit, and 1 Mbps super I2C communication line. But all those things are very complicated. I will not bring them up right now. We'll study it later on. And the data will be an 8-bit data. That will be sent from the slave to the master or from the master to the slave. Now, you just take a picture of all these things, note it down on a copy or a paper. I'll give you 2 minutes. I'll come back and I'll rub this out, because I will go deep into the protocol, that what happens. I'll just discuss 2 conditions. I will discuss 3 conditions. One is when the master starts a communication with an EEPROM or any of the slaves and starts to write some data. So that is the writing condition. So the first thing I will discuss is writing data. The second thing I will discuss is start, stop, acknowledge, not acknowledge. I know many of you will tell me, who are aware of this thing, that this is what the hell, you should discuss this first. But I will tell you no, because while discussing this, I will discuss this. But there are several things you must know which will not be covered over here, about start, stop, acknowledge and not acknowledge. And the third is reading of data and dummy write. Reading of data includes dummy write, so it doesn't make any sense to separate it in a topic. So these are the 3 things that I will discuss with you. It's very simple, nothing to worry about. I just want you to take a note of or a photo of this particular thing which I've drawn. I'll just give you maybe 5 minutes. I'll be back. Okay, till then, do it. Okay, so I'm back. I hope you've copied the data. I'll just erase it. So I hope you can see it clearly. Okay, so the first thing that you should know is that I2C communication consists of a few steps. That is, first there has to be a start condition. I don't know, the video is not coming clear, right? Maybe I should stop and record it in a higher resolution.